The deep ocean is full of giants. They're everywhere down there. But for some of the biggest animals on Earth, we almost never actually see them. In March 2025, researchers finally filmed a colossal squid alive in the wild for the very first time. 100 years after the species was named, it was barely a foot long. That's because it was a baby. So if the ocean is hiding 50-foot monsters, where exactly are they living, and how do we actually find them? You've probably heard the claim that we know more about the surface of the moon than the bottom of the ocean. That's actually false. Satellites use radar to measure tiny bumps in the ocean's surface caused by gravity. And from that, we've mapped the seafloor in impressive detail. The trenches, the underwater mountains, all of it. But that's the problem. Mapping the ocean floor is like mapping a forest by only looking at the dirt. Satellites can't see into the water itself or anything swimming in it. And the space between the surface and the seafloor isn't a flat map. It's a massive three-dimensional void. In a space that size, even a 50-foot animal is basically a speck of dust. We're not just guessing these giants exist. Sperm whales dive thousands of meters to hunt giant squid. And when they surface, their heads are covered in circular scars from suction cups fighting back. Most match known giant squid. But some scars are so much larger that scaling them up implies something bigger than any squid we've ever documented. And because whales can't digest the hard chitin beaks of squid, scientists regularly find thousands of beaks packed in their stomachs, including oddly shaped ones that don't match any known species on Earth. The proof is already inside them. Deep-sea animals have spent millions of years perfecting the ability to detect the tiniest vibration and the faintest glimmer of light. Our solution for finding them is a submarine with loud mechanical thrusters and blinding headlights. To them, it's a screaming metal tank falling out of the sky, and they clear out long before it arrives. Which is why almost every major deep-sea giant discovered in the last 50 years was found completely by accident. In 1976, a U.S. Navy vessel off Hawaii hauled up its parachute sea anchor and found a 16-foot shark tangled in the lines. The first megamouth shark ever recorded, a species science didn't even know existed. In 2007, a Shell oil company ROV checking underwater drilling equipment in the Gulf of Mexico stumbled onto a big fin squid drifting near the pipes, producing some of the clearest footage we have of the species. We're not finding these animals. We're bumping into them when they're not paying attention. The true giants of the ocean don't live on the seafloor. They live in the bathypelagic and abyssopelagic zones. The Midwater Void, an expanse of pitch-black water stretching for thousands of miles with no walls, no ceiling, and no floor. In a coral reef, a giant hides behind a rock. Out here, the only way to hide is to disappear entirely. Since red light barely penetrates the deep ocean, many of these animals evolved to be deep red or black, making them functionally invisible. Others, like glass squid, are almost completely transparent. An invisible animal in a boundless void isn't hiding from a camera. It simply isn't there to be found. Scientists eventually stopped hunting for the animal itself and started looking for what it leaves behind. Every living thing constantly sheds skin cells, mucus, and waste into the water. This is environmental DNA, or eDNA. Instead of chasing a giant squid with a loud submarine, researchers now lower a sterile bottle into the deep, scoop up a liter of water, and run it through a genetic sequencer, checking it against a global database of known species. A striking percentage of what comes back from the deep ocean doesn't match anything known to science. We have the genetic fingerprints of undiscovered animals sitting in a lab, without ever having seen them. Building thick bone and dense muscle takes calcium and calories that are scarce in the deep sea. So instead, some of the largest animals on Earth went the opposite direction and became jelly. In 2020, researchers exploring canyons off Western Australia found a glowing, string-like organism coiled in the water. Its outer ring alone measured roughly 150 feet across, likely making it the longest animal ever documented, longer than a blue whale. It was a Siphonophore, not a single body, but a colony of thousands of genetically identical specialized clones linked together. Some forming a stomach, others functioning as thrusters, others as stinging tentacles. Its full length was never precisely measured, since bringing something this fragile to the surface would cause it to disintegrate. If a loud, glowing submarine scares everything away, the answer is to go silent. Marine biologist Edith Witter built a camera system called the Medusa. No thrusters, no white light, just a red light camera invisible to deep-sea eyes. Attached to it is the E-jelly, a ring of blue LEDs that mimics the distress flash of a threatened jellyfish, which in the deep ocean signals one thing: an easy meal is nearby. In 2012, the team deployed the Medusa off the Ogasawara Islands in Japan. Out of the darkness, an actual giant squid slowly approached the light, the first time the species had ever been filmed alive in its own habitat. Decades of noisy submarines had failed. The moment scientists went quiet, the animal came to them. People love the idea of a 60-foot Megalodon hiding in the Mariana Trench. It's not realistic. The deep sea has almost no food, and a warm-blooded predator that size needs tens of thousands of calories a day just to function. It would starve within days. Deep-sea gigantism works because cold-blooded animals like squid and jellyfish can slow their metabolism to a crawl and go months without eating. But slow and energy efficient doesn't mean harmless. A colossal squid can weigh over 1,000 pounds with tentacle hooks that rotate to tear flesh on contact. And that harmless-looking Siphonophore is lined with millions of microscopic stinging cells capable of paralyzing anything that drifts into it. We can't always see these animals, but we can hear them. Sound travels roughly 4.5 times faster in water than in air, and scientists monitor the ocean using underwater microphones called hydrophones, originally built to track enemy submarines. They've picked up whale migrations, underwater earthquakes, and famously, the 1990s Bloop recording. Later identified as an ice quake, not a sea monster. But mixed in with all of that are thousands of hours of clicks and hums that still don't match any known animal. We know exactly what direction they're coming from. We just don't know what's making them. For millions of years, the deep ocean was too cold, too dark, and too pressurized for us to touch. That's changing fast as companies prepare industrial mining operations to strip rare metal nodules straight off the seafloor, deafening and choking the exact zones these undiscovered giants depend on. We might drive them to extinction before we ever officially prove they exist. We don't own the abyss. We're just visitors, shining a small flashlight into an endless void, and for now, it's still capable of keeping its secrets.